Assalamualaikum for student CEG243. Now we continue our lecture week 4. Topic 1, Physical Properties and Classification of Soil, week 4. We have program outcomes PO1 and PO2. Course outcomes CO1, CO2, and CO mapping CO1, PO1, CO2, PO2. You may read for all the PO outcomes and course outcomes here. Alright guys, now we go for the learning outcomes. At the end of the lecture, students should be able to understand consistency of fine-grained soils by using algebraic limit, liquid limit, plastic limit, and shrinkage limit, plasticity index, liquidity index, activity, plasticity chart, and laboratory determination of liquid limit and plastic limit. Okay, we go for the consistency of fine-grained soil. The consistency is specifically used for fine-grained soil. Consistency of the soil is defined to be its physical characteristic at a given water content, which are solid to semi-solid to plastic to liquid. Alright, from dry to wet. The water content at which the consistency changes from one stage to next are called consistency limit or algebraic limit. Alright, now this is soil consistency figure. If you look at here, we have volume air, volume solid, and then this one is volume, and this one is water content. We have solid, plastic, liquid. Alright, and then this is a water content acts as this. Alright, if we see here, we have a solid, semi-solid, plastic, liquid, and this one is the natural water content here. And then you have the plasticity index, which is water content for liquid limit minus plastic limit. Alright, liquid limit minus plastic limit is equal to plasticity index. Soil consistency. Alright, shrinkage limit. Alright, change of consistency from solid to semi-solid. Alright, plastic limit. Change of consistency from semi-solid to plastic. Liquid limit is change of consistency from plastic to liquid. Plasticity index, the difference between the liquid limit and plastic limit. Alright, this one is the plasticity index definition. It is in this range of water content that soil has a plastic consistency. So refer to the equation here. Plasticity index IP. Okay, IP is equal to liquid limit minus plastic limit. Water content for liquid limit minus water content for plastic limit. That one is plasticity index. Liquidity index, the measure of soil strength using algebraic limit and the relationship between the soil natural water content and its consistency limit. For example, its natural or in situ consistency is given by liquidity index. I is for index, L is liquidity, is equal to W minus WP over IP. W is natural or in situ water content. WP is water content for plastic limit. IP is plasticity index. Remember, I is for index. W is for water content. Alright, so you will see here, this one is how to classify the liquidity index. For IL less than 0 is classified as semi-solid or solid. Or IL is between 0 to 1 is classified as plastic. If IL is more than 1, soil is in liquid state. Now we go for the equation for activity. Activity is a ratio between plasticity index and percentage of clay fraction for the clay with particle size less than 2 μm. Okay, the degree of plasticity related to the clay content is called the activity of the soil. All right. If you see here, the activity used as an index property to determine the swelling and shrinkage potential of expansive soil, right? Alright, so this is the equation for activity. Activity is equal to IP over percentage of clay particles less than 2 mu m. What is IP? I is index, P is plasticity. So meaning that IP is plasticity index. Alright. Alright guys, look at this table. This is activity, the value of activity that we calculate just now, and this is soil type and the minerals. Alright, so you may refer to the activity value and then you will know the type of soil and mineral. If the value activity is more than 1.25, when the soil mixed with water, it will experience great swelling, and while it in dry condition is tend to shrinkage in large amount. The soil is not suitable for the construction of building on it because it can cause the settlement of the building, or the building will curl upward at the edge and most likely crack. Alright, so if you know that if the activity is more than 1 to 5, this is the effect, right? Plasticity chart. Measure of liquid and plastic limit value in the British Standard Soil Classification System. Alright. Fine soil are divided into 10 classes based on their major plasticity index and liquid limit values. Clay are distinguished from silt, and 5 divisions of plasticity are defined as given below. Okay, this is a plasticity chart. If we see here, we see the plasticity index versus liquid limit. So from the plasticity index and liquid limit, you will classify the soil. Okay, you have to plot. Alright, so if you get the CH or MH, you have to know that CH is stand for clay of high plasticity. MH, silt of high plasticity. CV, clay of very high plasticity. CE, clay extremely high plasticity. Alright, so this is how we classify the soil based on plasticity chart. Alright, so from the plasticity chart, you will see that uh, the value of a chart is actually based on the value of moisture content or water content for liquid limit and also plasticity index. So this one is for low plasticity, the liquid limit is less than 35%. For extremely high plasticity, the moisture content is more than 90%. Okay, it can be up to 120%, 130%. Alright, so you may refer to this example. You have the moisture content of 30% and 5% of the fine particle was carried out for compenetration tests in the geotechnical laboratory. The results show the plastic limit of the soil is 25% and the liquid limit is 64%. So you have to determine the plasticity index, liquidity index, activity, and soil classification. So you have to do by yourself, and then you have to refer to the equation that we already provide for you before, right? Okay guys, you may refer to this video for the cone penetration, cone penetrometer test, Casagrande test, and then plastic limit testing. Alright. Okay, this one is cone penetrometer apparatus. Okay, used for cone penetration test. Alright guys, this is a compenetrometer apparatus diagram. So you will see the diagram, how to read. This is the dial gauge, and then this is the needles, and then the metal cup. So this is the apparatus and material that going to use to determine the value of uh, plastic limit, plasticity index, and liquid limit. Okay, this is the Stages involved in testing. First is you have to do the sample preparation, mixing with water, maturing, remixing, placing in a cup, setting up the cone penetrometer, measuring the cone penetration, master content determination, remixing and repeat test, calculation and result. This is the stages involved. Alright guys, this is first step, sample preparation, mixing with water. You may refer how to mix here. This is process of maturing. Step number 4, remixing. Okay, you have to read one by one here. Step number 5, placing in cup. This is cone penetration cup. Then you have to trim here. Then we have to setting up the cone penetrometer apparatus. Measuring cone penetration. Please refer to this procedure. Step number 8, moisture content determination. This is the example of the result from the cone penetration test. If you see here, we have cone penetration value in mm. We have the mass of container and wet soil, mass of container and dry soil, and then you can calculate the dry soil and moisture loss and the moisture content here. How to determine the moisture content is the moisture loss divided by dry soil times 100%. Step number 9, remixing and repeat the test. Step number 10, calculation. Calculate the moisture content of each test sample, and then the penetration value, and then you have to plot the penetration versus the moisture content, and then you find the linear scale on the graph, and then plot the relationship between the moisture content with the penetration recorded on the linear chart. Alright, this is the example of typical result from the cone penetration test. Okay, if you see here, we have test number 1, 2, 3, and 4, and the cone penetration value, you have 2 or maybe 3 because we repeat the value of cone penetration to make sure that the value is valid. If it says that you take two value, 15.5 and 15, so it's okay. If it says that you take a 15.5 and then 30, so you have to add another value of cone penetration. Alright, so if you look at here, we have the value of average penetration and also moisture content here. Alright. Okay, next step is graph plot. We have plot penetration versus moisture content. Alright, so this is the straight line, the linear, alright, straight line, best fit straight line. Alright, and then you will get the result from the graph. Read off the moisture content corresponding to a cone penetration of 20 mm to the first decimal place. Alright. Okay, for example here, okay, you plot the graph and then you will get the straight line, the best fit line, and then you find the value of penetration 20 mm, and then you plot here and you will get the value of liquid limit here. Okay, at 20 mm penetration to the nearest. For example, here liquid limit is 68%. Alright, this one is second test that we can use for soil classification for fine soil, which is Casagrande test. Okay, this is the cup for Casagrande test. Alright guys, this is apparatus. Okay, diagram for apparatus for Casagrande test. Alright, this is all the apparatus used to perform the Casagrande test. For Casagrande test, its stages involved in testing is first sample preparation, mixing with water, maturing, remixing, setting the equipment, placing salt in the Casagrande cup, applying the groove, applying the blows and taps, moisture content determination, remixing and repeat test, calculation, and you will get the result. First is explanation for sample preparation. Step 2, mixing with water. Step 3, maturing. Step 4, remixing. Step 5, setting up the equipment. Step 6, placing in Casagrande cup. Step 7, applying the groove. Alright, if you see here, you will see the movement of grooving tools. Okay, grooving tools positioned at the center of the cup. And then this is the cannula created using the tip of the grooving tools. The groove before applying the blows and bumps. This is the groove mark and cannula. Step number 8, applying the blows or taps. Alright, you have to record the number of bumps required. The groove after applying the blows and bumps. The groove mark and cannula is closed at a length of 13 mm. Look at this. This is 13 mm. Step number 9, moisture content determination. Alright guys, this is the result of Casagrande test. For example, this one for test number 1, the first test. The moisture content is 54.86. To determine the moisture content, the moisture loss divided by dry soil times 100%. Alright, so step number 10, remixing and repeat the test. Repeat the test at least 3 more times using the same sample of soil. A further increment of distilled water have been added, proceeding from the drier state to the wetter. Alright, this is step number 11, calculation. X-axis, number of tap count or number of blows. Y-axis, moisture content. You have to draw a line of best fit between the point. Alright, please draw a line of best fit, not draw a curve. Alright, it should be a line of best fit. Alright, this is example of test. We have 5 tests here. Number of taps or bumps or number of blows here. If you see here, First is 58 and this one is 15. Why? Because this one is a more drier and this one is more wetter. Alright, so you see here we have the container number and then you have to determine the value of moisture loss and the moisture content. Alright, if you see here, the moisture content is increasing. Okay, and then the number of blows is decreasing. This is how we plot the graph. You have the moisture content at y-axis, and then you have the number of taps or number of blows or number of bump for x-axis. And then you have to draw best fit straight line. Remember, straight line. Step number 12, result from the graph, read off the moisture content corresponding to the 25 taps or 25 number of blows to the first decimal place. Alright, this one is example of the graph plotting. We have the moisture content versus number of taps or number of blows. And then you have to find the liquid limit at 25 number of blows here. This one is 25 and then you find the value of moisture content, which is liquid limit here. For example, is 73%. Right? Intercept of the 25 taps line with the best fit line. Plastic limit test. Stages involved in testing is we have 12 stages from the sample preparation to the results. Alright, so we have step number 1 to step number 3. For the step, you just follow the previous step when we are applying for the Casagrande test and cone penetration test. So now we continue step number 4, remixing. So you have to remove 20 grams of the soil from the container after maturing and transfer the soil to the glass plate and remix it with the palette knife for 10 minutes. To obtain uniform distribution of water throughout the sample. And then after that, you have to dry it. Allow the soil to dry partially on the palette until it becomes plastic enough to be shaped it into a ball. And then we have to create ball shape from the sample. Now we continue step number 7, hand drying. Mold the ball of the soil between the finger and roll it between the palm on the hand until the heat of the hand has dried. The soil sufficient for slight crack to appear on its surface. Step number 8, dividing samples. Divide the sample into 2 subsamples of about 10 grams each and carry out a separate determination of each portion. Each portion further divide into 4 more smaller parts. Okay, you look at the figure here. Okay, 10, 10, and then you have to divide into 4 more smaller parts. Step number 9, rolling and trading. Mold the soil in the finger to equalize the distribution of moisture. Then form the soil into thread about 6 mm diameter between the first finger and thumb of each hand. Roll the thread to reduce to 3 mm to 5 to 10 complete forward and backward movement of the hand. Step number 10, crumbling point. Mold it between the finger to dry it further. The first crumbling point is the plastic limits. Okay, look at that. This is 3 mm diameter and then cracking here. This is an example how we do it. Moisture content determination. Take a moisture content sample of all the samples. Alright, this one is the samples fall into the moisture content tin and then you put in the oven for 24 hours to get the moisture content. This is the example result for the plastic limit test for the moisture content result. Alright, so we see here we have container number 1 and 2. A and B, and then you will determine the value of moisture loss and the moisture content. And then from the moisture content, you will get the average moisture content. The average moisture content we call as the plastic limit. Alright guys, from the value of liquid limit you get from the Casagrande test or compenetration test, you will use the value to plot here. And then if you see here, this one is plasticity index. Plasticity index is equal to liquid limit minus plastic limit. Plastic limit value is taken from the plastic limit test. Just now we learned how to determine the liquid limit and plastic limit. So the reason is because we want to classify the soil and plot the plasticity chart. For example, you get the value of liquid limit is 40% and the plasticity index is you will get, for example, you get 20. So 40, 20, so you will classify the soil as CI. Clay of intermediate plasticity. Okay, if you get the value of CH, clay of high plasticity. If you get the value of MV, silt of very high plasticity. It's like that. It's very simple. Alright, guys. Success is the sum of small efforts repeated day in and day out. Thank you, guys.